So in a web browser, there's usually a debugger, and we're going to use that pretty intensely. So first thing you want to do is open it up. It depends on the browser. In Chrome, it's I'll have to find it. I know the shortcut, but if you guys don't, click on this thing, and then Tools, and then JavaScript Console. And in Firefox, it's something different. So here's Firefox. I just want to show you guys how to open the terminal here. Here it is. It's under Tools, Web Developer, and Web Console. So there it is. But I'm going to use Chrome. So the first thing I'll do is just an interactive sort of session in this terminal to show you the JavaScript language and how the language works, what kind of language it is. I wonder if I can make this bigger. Yeah. So hello world is like this: console.log, in quotes, hello world. So it printed out hello world for us. Console.log is something given to us by the browser, and it's common to most, every browser. There's console.log. There's console.other things, but console.log is really what we need to know about. So this is how I like to debug. Print out a statement. JavaScript has numbers, so you could do things like 1 plus 1 is 2, 2 plus 2 is 4. In JavaScript, there's only the type number. There's not float and int like in other languages. So it's just something to be aware of. So if there's an API that demands a floating point number, you can give it 2, and it's okay in JavaScript. You don't have to type 2.0. There are strings. Strings can be enclosed in double quotes or single quotes. That's something a little bit different about JavaScript, because in other languages, single quotes means character, but not in JavaScript. It's a string also. JavaScript has arrays, and you can make arrays with square brackets. So square bracket 1, comma 2, comma 3 is an array with 3 things in it. And JavaScript is loosely typed, unlike Java or C++. So that means an array can have different kinds of things. These arrays are not all the same type. So for example, you can say 1, 2, 3, hello, and that works. You can use variables, and to declare a variable, you use the keyword var. Var x equals 5. What you're seeing is the return value, by the way. So it says undefined, but it actually has defined x in the global scope of the page. So if you type x, it evaluates x. And in JavaScript, the semicolon rule is a bit flexible. You don't really need the semicolon. It'll still work without it. But, I like to keep it there just so that it's clear. There might be some weird side effects if you leave it out in certain cases. So there are also objects in JavaScript. And in JavaScript, objects are key value pairs. And in other languages, this is called a map, or a hash map, hash table, dictionary. And the way you specify objects is with curly braces. So this just creates an object with nothing in it. And the curly braces, within the curly braces, you can have a series of key value pairs. And so if the key is foo, and you want the value to be the string bar, it looks like this. It's separated by a semicolon. Oh yeah, colon, sorry. It's separated by a colon, not a semicolon. I misspoke. So if we say var x equals and then create that object. And we evaluate x. Oh, it gives us this little explorer for the object, so we can see it's actually in there. And then we can type x dot foo, and it will give us bar. So in other languages, you need to specify like classes and then create an instance of the class to get objects, but not in JavaScript. In JavaScript, all objects are these key value pairs. And I'll introduce the idea of prototypal inheritance in JavaScript, but we're not really going to use it much. But I just want you guys to be aware of it. In other languages, there's like class and then subclass, stuff like that. You can build up a class hierarchy. But JavaScript is not really class-based. It's based on prototypes of objects. So that means that you can create something like, what's a good example? Var person equals an object. Oh, what would be a subclass? Let's come up with some ideas. What would be a subclass of person that would have a property that a normal person wouldn't?
Agenda.
Agenda?
Gender.
Gender. Gender would be a property of all people. So gender is undefined, I guess. You'll have to define it once you make the object. Or let's say I don't know, what should the default be? I mean, that's a tricky question. This is a bad example. Let's say name. Name is a string. Oh, this is sorry. I should have came up with an example beforehand. Let's just do like foo.bar. I want to show you the fundamental essence of it. So let's say we're going to make a class. It's not really a class, but we can think of it as a class. So I'll use an uppercase as the convention. So var foo as a class equals some object, and a foo has x, and it's 5. Say the default is 5. And then, well, I'll make it more interesting. I'll make y also is 10. So foo is just an object, but we can actually inherit from it in a way by using var. So bar is going to be like a subclass that overrides one of the things of foo. So var bar equals object dot create, and in JavaScript, object dot create creates a new object that inherits from a prototype that you give it. So there are two arguments to object.create. The first one is the prototype, so which is foo. And then the second is an object that you could think of as like a mask that goes over top of the inherited prototype. So let's say we'll give this x equals 500. Oh, property description. Right. So this is sort of a newer convention in JavaScript, this object.create thing. So you specify the value is 500. And with this way of creating objects, you can actually specify like privacy of it, like it's only readable, you can't write it. But I'm not going to get into that. But the point is, the second argument, I forgot. I thought it was an object, but it's actually a descriptor object that describes the properties of the object. And you can also do, with this, you can do things like setters and getters. You can define functions where when you say like bar.x equals 5, it would actually call a function. And you can do something like trigger events, stuff like that. So if you want to learn more, just Google object.create. But I'll just do this for now. So we have bar bar.y. It should be 10. This is the value that's inherited from the prototype. And it is. But bar.x, the default value, the prototype value is 5, but we've given this x a value of 500, so this will give us 500. So this is the way you do inheritance in JavaScript. You have a prototype, you inherit from it, and then that new object can actually be a prototype for newer objects. And so it's a prototype chain rather than a class hierarchy, a superclass hierarchy. So that concludes the kind of introduction in the console. Now let's create a page and make some graphics on it. So I'll make this smaller again. So open up a text editor and create a file called index.html. So I have an empty directory. I'm going to use Vim and create index.html. The capitalization doesn't matter on, And we're going to create a bare bones HTML page that has like the bare minimum HTML. So in HTML, there's a notion of tags. How many of you have done HTML before? How many of you have spent more than 10 hours writing web code? Okay, so I'll cover everything. This right here, it's cut off. Hold on a second. I'll move it so you can see. So these are called tags, and the first tag is an opening tag, and the second tag is a closing tag, and the differentiating thing is that slash. So this is like the HTML tag. The whole HTML page goes inside these tags, and there's two main parts of an HTML page. There's the head of it that gets loaded before anything else. That doesn't put anything on the page, but it does things like load scripts that you need and load style sheets. And then there's the body of the page that has the actual elements that you see. So it looks like this. Head, and we say not head as the way of speaking it. But that's the closing tag for the head part. And then body, and then not body. And then in the head, for all the pages I create, I like to specify a title. This is an example of something that goes in the head. So you could say title, and then not title. See, the opening and closing can be on the same line. And then inside of this, you put the text, like hello canvas. And then in the body, I'm going to type just hello, just so we have something to see. So I'm going to save this file. I'm going to figure out where I am, where the file is. I'm going to copy that to the clipboard. You could just select it, copy, or whatever. And then just paste it in the URL bar here in the browser. And click on the file. So, I'll move this over too. It's getting cut off on the projector. So notice the effect of the two things that we put in there. There's Hello Canvas showing up here as the title of the page. That's the function of title in the head tag. It shows up here. And it shows up like if you were to bookmark the page. And here's the page. Hello HTML, I should have typed. So I want to get a sense. You guys are with your laptops. Are you with me?
Yes.
Is there any hang-ups, like getting the page open? Anybody lagging behind? No? I mean, let me know. I mean, I'll wait. I don't want anybody to like be way behind and then not get it. So the next thing I'm going to do, I'll delete this hello, and in the body, put a canvas. Canvas and not canvas. So canvas is it's something new in HTML5. It was developed by Apple around 2004, and it's a 2D graphics API. So it for web pages. So what that means is it's like an image tag in a way. Like an image tag is a rectangle on the screen that has a width and a height in pixels. But this canvas object is like an image, but you can actually change what is displaying using JavaScript code. So you could do things like call a function draw circle, and it will draw the actual circle on the page. And there's a very rich set of things you can do in the canvas. Like you can draw all kinds of different shapes, and you could do things like drop shadows. You could draw text. You can draw images and like resize the images, transform the colors of the pixels of an image. So that's what we're going to learn today, like the basics of this canvas technology.
This is only for the 2D, not for the 3D.
Well, actually, there's another part of HTML called WebGL, which is OpenGL running in the browser, and that actually uses the canvas tag also. But the canvas tag, like, it's just a way to interface to the technology that's inside the browser. So actually, yeah, you can make 3D stuff with the canvas through WebGL, and I'll point out later on how you can, like, the starting point for that. So now let's do this. After the canvas and inside the body, let's create a script tag. Script and not script. And what this is everything in here is JavaScript code. So if you type in here console.log hello JS, I'm going to save the file, and then I'll refresh the page, and you see it's printed here, hello.js. It's executed that code. And the reason I put it after the canvas tag is so that the canvas tag is defined before running that code. So you don't have to do anything complicated. I mean, it's not that complicated. In practice, you would like add an event listener to the page to wait until the body's completely loaded and then run your code. But instead of doing that, I'll just run the code right after it's defined, because the way it works when you open up an HTML file, it loads each thing sequentially on the page. So it defines the canvas object, and then it runs the script. So it'll be there. And that's why I put the script there. You can put the script anywhere. You can even put script in the head. That is guaranteed to run before the body's loaded. So what we want to do is, from this JavaScript code, we want to access this canvas thing. And the way we do that is we need to give the canvas an ID. So in HTML, whoops, what have I done? You can give it an ID like this. Add a space before the closing of that thing. ID equals canvas. I mean, it could be anything. The ID could be anything. It's a name. And these are called attributes of tags, by the way. There's attributes to all kinds of tags. Like if you wanted to put the script in a file, you would do this. src equals script.js. And then the script gets loaded from that file. But I'm just going to keep it in here for now. So we've given the canvas an ID. And in the JavaScript, here's how we get at it. We say document dot get element by ID. And we give it a string. And the string is the name of the element that we want, so we give it canvas. So that's going nowhere. Let's assign it to a variable. Var canvas equals that. So it's confusing in a way that there's 3 instances of canvas on the page with 3 different meanings. I just want to explain that this is the canvas tag, which is part of HTML. This is the name for the canvas, which needs to match this name given here. When you look it up by ID, it needs to match. And then this canvas is a local, well, it's global. It's a variable that the canvas HTML node is stored in. So that's like one step closer. And the next thing we need to do is get the drawing context of the canvas. And that's the thing that has functions like draw circle. Yeah, question.
Is this a standard of keeping the name same or?
Oh no, I mean it could be any. No, I just prefer it because it's very clear.
Because keeping the canvas name, saying that the tag is confusing to me. Like,
Yeah, maybe I should just change it just for the sake of clarity. Like this should be
My canvas.
my canvas, and this should be the canvas. And so this needs to match. This needs to be my. You don't have to do this if you don't want to. But just that's a good point. Thanks for. I mean, yeah. So just so it's very clear that there are 3 different things.
and how is my canvas different from the canvas?
The canvas is this JavaScript variable that's in the code that we can access, and my canvas is the ID of the HTML element. And precisely, it's called a DOM element. DOM, D-O-M, stands for Document Object Model. And when you create an HTML page, this is actually a tree of these nodes, where the root is HTML, and there are 2 children of HTML. There's head and body. And within body, there's children, canvas, and script. So it's a tree structure. That's called the DOM. People refer to that as the DOM. So the DOM has nodes in the tree, and each node has, optionally, an ID. So if I were just to, in here, try to refer to my canvas dot something, it wouldn't work because it doesn't assign these DOM objects to variables in the JavaScript namespace. But you can get at them with this DOM function call, document.getElementById. So document is actually part of the DOM API, or like the DOM standard, the HTML standard, where you can access the elements of the page. It's a whole huge set of functions that do all kinds of things. But this is all we need for now. One of the things is get element by the ID. So that's how you look up in the tree structure that element that has the ID, that particular ID. So that's implemented somehow. I don't know how, but it gets you that element of the tree. And then that element has functions on it, which is defined. You could just Google HTML5 canvas specification, and you'll get all the functions that are there. But one of the functions is get context. So I'm going to assign that to a variable because we'll need it. Var. I'm just going to call it C because we're going to have to type it a lot. C equals the canvas dot get context. And here you pass it 2D. And that gives you the 2D drawing context. But if you wanted to use WebGL, I think you would pass it WebGL. Or maybe 3D. That would make more sense. I don't know. You can look it up. But the argument is different if you want to use WebGL. If you want to use the Canvas API, you need to pass 2D. Get the 2D drawing context. So we've created 2 variables here. And I just want to point out that the convention in JavaScript is to declare all the variables at the top in one list of variable declarations. But you don't need to type var. It could be actually, you can remove the var, and I like to indent it so it's clear. And then over here, instead of a semicolon, if you use a comma instead, it creates a bunch of variables, and it's cleaner in a way. Let me just go back to the terminal here to illustrate that. So you could do something like var a equals 2, comma, b equals 6. And you've defined a and b together on the same line. And that's just, I like to do that. And just something you should be aware. If you see JavaScript code with the comma, it's just declaring multiple variables. Yeah?
Is that like a tuple type, or is it just a convention?
Oh, no, it's not a tuple. I mean, it's the exact same thing as saying
It's like in C, right?
var a equals 2, semicolon, var b equals 6. These two lines do the exact same thing. There's no difference whatsoever. And you could separate, you could do var a equals 2, and then after that, var b equals 6. They do the exact same thing. They just define these two variables. And, well, yeah, so first let's draw something on the page. So we've got the context that has the drawing functions in it. And let's just call one of them. I happen to know that there's a function called fillRect that will fill a rectangle with the color that's currently being used, and the default color is black. So the first thing we'll do is draw a rectangle. So c.fillRect, and it takes 4 arguments: the x, y, width, and height of the rectangle you want to draw in pixels. So what's the question?
Does it have a convention where it measures from center or from top left? Or
Yeah, we'll cover that. So I'll draw from 0, 0, and then 10, 10. And we'll see where it ends up on the page. So this is x, y, width, height. So just to make it clear, I'll make those variables x, y, width, height. And then I'll make more variables. Oh, it's indenting for me. X equals 0, y equals 0, width equals 10, height equals 10. So when we look at the page, it's drawn there. It's a tiny little rectangle. I'll try to keep the code and the page showing in parallel. So yeah, the answer to the question, what's the convention, like what's the coordinate space look like? 0, 0 is in the upper left corner. And if we look at the elements of the page, we can actually see where the canvas starts. See, it's actually right up against the edge of the canvas there. But by default, there's some padding around all the HTML elements on the page. And actually, we can get rid of that padding with a certain snippet of code that I had pulled up. Is there a question?
Yeah. Can you move the canvas just using more HTML alignments?
Oh yeah, the question is, can you move the canvas using HTML alignments? Yeah, it's like any HTML element. So anything you could do with, say, an image, img tag, you can do with the canvas. It fits into the HTML conventions and whatnot. So you could insert it between pieces of text, for example, and make a little animation or something like that. So I'd like to get rid of that margin and have it flush with the edge of the screen. And I figured it out once before by Googling and researching. And the way you do it is by adding some CSS to the body tag. It's kind of, HTML voodoo. I don't really know what's going on completely. But you're adding a little bit of CSS, inline CSS it's called. So you could type style equals, in quotes, margin colon 0, px for pixels, and then a semicolon. So now if I open that, yeah, it's flush up against the edge. So I prefer that. And notice how big the canvas is. It's 300 by 150. That's kind of a random, unexpected size. That's the default. So usually when you write code, it's better to specify the size. Question?
Is that defined by the browser, or is it defined by the standard?
Yeah. Is it defined by the browser or the standard? I don't know. The default, my guess would be it could be different from browser to browser.
It did work on Firefox too.
Firefox is the same size?
Yeah.
So, okay.
Adding a margin did move it.
It did not work? It did.
I wasn't able to see the whole area because we don't have this HTML elements.
So in Firefox, does this little snippet of the style push it to the edge? Okay, good. So let's do something. So I want to make sure everybody's here. Is anybody stuck? No? Is it working? So now that we've got this little square on the screen, we can do things like change the color. The way you do that is c.fill style equals, and you give it a string, say blue, and it turns blue. And it's pretty small. I'm gonna make it a little bit bigger, like 100 by 100. So there's in graphics programming, there's a notion of the state of the graphics API. So fill style is part of that state. So if I were to draw another rectangle, so I just copy and pasted that line of code, and in between those two lines, I will increment x by 150. X plus equals. So x equals x plus 150 in JavaScript and most languages. It's the same as saying x plus equals 150. So what should this do? I'm looking for an answer. I want someone to actually answer. You just shout it out.
Oh, it will shift the box over 150 pixels over to the right.
To the right. Yeah, exactly. So if I save this and refresh, I'll get another one. And notice that it's also blue. Why is it also blue? It's because the fill style was set to blue, and then it was used, and then it was used again. So if we want to make the second one a different color, I'm going to copy that line and paste it down here. C.fill style equals red. So that's the notion of the state of the color. And there are other things like that. Like you could do things like stroke it, which means draw an outline around it. Question?
If you are changing the style before you fill the rectangle, is there a way you can change the style afterwards and do it all so that it changes the color?
Oh yeah, you mean you want to have a thing that's actually like changing color, like animated.
No, not necessarily, but just that you have to remember to set the style before you actually execute the line that fills the rectangle.
Yeah.
You can't go back and change
Go.
the color of the rectangle after it's been.
I'm not sure I get what you're saying.
I think I understand that. You have to set it before you draw it.
Yeah, you set it and then you draw. And whatever you're drawing uses that current color that's been set. So if you don't set the color, um, in the earlier case, I knew it was going to be black because there's no other code running on the page, and it's going to be black because that's the default. But if you are running code in some other environment where there's other code running and you don't set the color and you draw something, it could be like some random color that was set by some other piece of code. So you just need, it's better to always set the color. Question?
Is there any sort of block scope? So if I call a function and rechange the fill style and exit the function,
No.
what happens
No, the state persists.
across everything?
So if you set, no matter where you call c.fillStyle, if it's the same C object, it'll stay. So the question was, if you have a function and you call c.fillStyle equals blue inside the function, will that setting stay after after it's exited the function? And the answer is yes. It's just an object that gets mutated.
So say you add a second script block below that one, and you try to reference C. Will it be the same?
Oh. Yeah, it will, because we're actually working within the global scope right now. So any script that's loaded on the page would be able to see all of these variables, which is actually bad practice.
Does each context return the same object, or are they each different?
Does each context?
Say you get context, I get C, and then if I call get context again, is that another referencing the same thing?
I believe it is if you call it on the same canvas element object. Yeah. But if you have a different canvas on the page and you call .getContext on that other canvas, it'll be a different object that will affect that other canvas. So you can have multiple canvases on the page with different IDs and look them up.
Does the function fillStyle and fillRect return something? Like, can you assign that to something?
Notice it's not a function call, it's just an assignment.
Oh.
So it's an assignment of the property fillStyle on that object C, which is the context. So
That's a function.
fillRect is a function. Yeah, I don't know if it returns anything. It just it's just executed for its side effect, but we can print out the return value and see what it is. I'm curious. So that should appear here in the terminal. Undefined. Yeah, it doesn't return anything. Which makes sense because it just does, it has executed for its side effect. So one thing I didn't introduce earlier is functions in JavaScript. I want to go back to, I want to close this thing. I only want to see the script part. There we go. So I'm going to introduce functions in JavaScript. So functions in JavaScript are also objects. Everything in JavaScript is an object. So you can do things like assign a variable to a function. So like var square. It'll take as input one number, and it will square that number and give you the result. Var square equals function. And then parentheses for the arguments list, and then curly braces for the body of the function. And this actually creates a lexical closure. So variables you define inside that body are not accessible outside of that body. So as arguments, it'll take one number, x. In other languages, you might have to type like float x, but not in JavaScript. It's loosely typed. It uses a thing called duck typing. If you were to categorize it, like how is it typed? Duck typing. Like if it walks like a duck and quacks like a duck, it's a duck. Meaning, it's just an object, and if you call a certain function, and you expect it to be there, it should be there, and it should get called. So it's a little bit, in that respect, JavaScript's a little bit dangerous, because if you're calling a function on an object, you don't really know if it's going to be there. It's like you just need to read the documentation and hope it's right. So that's one people critique JavaScript and other languages are like that, like Ruby, and I think Python. I'm not sure. Ruby is definitely like that. Python is duck typed also. So it gives you a little bit more nicer syntax, but it's also a little bit dangerous because like there's no compilation and the compiler can't check if you're like calling the right function with the right arguments. So X is an object that we get in. And here in the body, we return a value with the keyword return, like in other languages. So if we return X, it'll just give you the same value you passed in. Let's return X times X. So now we can call square of X. And wait, what's X? Oh, it's 150. I was thinking, sorry, that's from earlier. Well, let's square 5. We get 25. So it works. And let's do a recursive function. You guys know about the factorial? Like n factorial is defined as n times n minus 1 factorial, unless n is 1, in which case 1 is returned. So let's var factorial equals a function that just has one argument, let's say x. It returns, what it returns depends. It really depends. I'm going to use the ternary operator. Let me introduce that first. So this will do nothing for now, but I want to introduce this other concept first. So var a equals true 5, otherwise 10. So this is called the ternary operator. It's in a lot of languages, and it's also in JavaScript. And what it does is, this is a Boolean. It could be a function call or a condition, if I is less than 2 or whatever. If it's true, this whole statement evaluates to 5, and if it's false, it evaluates to 10. So if A, we look at it, it's 5. Actually, I don't need to use a variable here. I just want to see the result. And true is a keyword in JavaScript. It means true. It's a Boolean. And so if this is false, it returns 10. So instead of using an if statement, I'm just going to use this notation so I can write the factorial function on one line. So here's what I have from before. Var factorial equals function x returns the same thing you pass into it. So I'm going to return, on some condition, I'm going to return 1. Otherwise, I'm going to return the recursive call to factorial. And I'm going to pass it x minus 1. And what's that condition that should hold? If x equals 1, then we should return 1. So x equals does equality testing 1. What if we give this function as input a negative number? What will happen? It'll do an infinite recursion thing. So let's, instead of equal, I'm going to use less than or equal to, just to play it safe. So then we can pass it negative numbers and it won't crash the whole system. Question?
Yeah, isn't it x times factorial?
Oh yeah, you're right. It's the wrong definition. X times factorial. Yeah, that's right. So 5 factorial is 5 times 4 times 3 times 2 times 1. So let's try it. Factorial of 3 should be, what? 3 times 2 should be 6. And it worked. Factorial of 4 should be 6 times 4. Yeah, so it works. So that's basically the syntax, how you define functions. And there's another syntax. I wanted to use the var notation because it's very clear that, like, okay, we're defining a variable. But more commonly, what you see in JavaScript is like this. This notation is also correct, and it does the exact same thing as the other notation. It actually defines a variable and sets it equal to that function. See, it's function and then the name and then the rest of it. Whoops, what have I done? Oh, I moved some things around by mistake. So that works. So this is kind of a preliminary thing to what we're going to do next. So I want to introduce animation on the canvas. How do you animate things? Yeah, you draw things over and over and over, and in between you clear the canvas, what's there. So I'm going to get rid of everything except this. And I'm going to make a function called render. And this is what's going to get called over and over and over again. And I'm going to put the c.fillRect inside of this function. And I'm going to put the xy width height also inside that function. But you got to be careful when you do that because there's a comma at the end of this line that needs to be changed to a semicolon. And you need to put var at the beginning here. And there are also for loops in JavaScript. Here's what a for loop looks like. For var I equals 0. It's a lot like C or Java. I is less than 5, I plus plus, and you give it a body. So I'm going to use a for loop. So you print in 1, 2, 3, 4. So I'm going to draw a couple rectangles. Question?
When it relates to animation, can you put a delay?
Oh yeah.
How fast the loop is running.
Yeah, actually, yeah. Before I do the for loop, I'll just set up the animation, so it's clear what's going to be going on. So in JavaScript, there's a function called set. Well, these two functions: set interval, set timeout. Set timeout executes a function after some time, once, and set interval executes a function periodically with a given interval between, and you specify in milliseconds, I think. So if you set interval and call it with a function, I already have an x, so I'm going to use it, x plus plus. So this function will, I need to also call, give it 1,000 milliseconds is 1 second. So every second, this will print out the value of x. And also, it will change the value of x by incrementing it by 1. So once I hit enter, this will start doing things every second. So the value of x, I don't know why it returned 1. Oh, 1 is the ID of that interval in case you want to cancel it later. There's also a function called clear interval, and you can give it that number, which is the ID of that running thing. It's almost like a thread, but JavaScript is single-threaded. So this is the mechanism we're going to use to tell it to clear and redraw the scene. If I clear interval and give it 1, because I remember that's the ID that was returned, it should stop. Yeah, so it stopped. So over here I'm going to use also set interval. Two things, a function and a time. So the function I'll give it is this render function, which we've defined. And remember, this function definition syntax is the same exact thing as saying var render equals function like this. No arguments, but it does that. It does that thing. So set interval render. So I'm passing it in the function, the render function, and a time in milliseconds. So let's say every half a second for now, it'll do this. So if I refresh the page, what's going to happen? Yeah, it's going to look the same because it's just redrawing the same thing in the same spot over and over again. So we need to have something changing. So I'm going to introduce a global variable called time. And I'm going to initialize it to 0. And then every time we render, I'll increment time by some small number, point 1. Or no, I'll do 1. Whoops. So time plus equals 1. So every frame, time is going to increment by 1. And I'll just separate these out here. It keeps doing that darn thing. So here I'm going to set x to be time. And what this should do is what? Time's increasing, meaning x is going to increase by 1 pixel every frame. Slowly it should move to the right. So there it goes. But notice it's not a square that's moving, it's a rectangle that's getting bigger. So let me, because we're not clearing the original canvas. That's the problem. But to make it exciting, I'm going to change this time to be 20 milliseconds.
What happens when it breaks off?
Oh, it just clips. It just, see, we're going to see it hit the edge. It just hit the edge of the canvas. It's still trying to draw, but not succeeding because there's nothing there. Yep.
If you were running this on a faster computer, would it refresh faster?
No, because we've specified 20 milliseconds. It should wait 20 milliseconds.
Oh, good. It's not based on how fast the system is running.
No.
Not like
No.
those really old games. Like
Right. Yeah, the old games, they're dependent on the speed of the machine. Right, right.
But if you try to play it on like a Pentium or something, it's rain. It's freaking rain.
Yeah. I know.
If you did that while loop instead of set interval, it would be as fast.
Yeah.
Actually, that's an interesting point. He mentioned if you were to use a while loop, it would just redraw at the speed depending on the speed of the computer. But actually, JavaScript is single-threaded. So if you try to draw it in a while loop, oh, and the way the canvas is implemented is only when there's a break in JavaScript execution does it actually refresh what's shown on the screen. So there's an event loop in JavaScript, and that single thread is most of the time idle in this case, but every 20 seconds that single thread gets, it calls this function render. And if it were to be done in a while loop, it would just draw everything, and then after it drew everything, it would refresh. So that's why you need to delay the execution of the code with something like set interval. So let's fix this clearing issue. So before we do anything, it's c.clearRect. I just happen to remember. I mean, you can look all this stuff up, and it's much like fillRect. It takes x, y, width, height, and I want to clear the whole thing, the whole canvas. So I'm going to give it 0, 0, first of all, And then the canvas object actually has these properties, width and height, that we can use. So I'm going to use the canvas.width, the canvas.height. So, and it's doing it every frame. So now we should see a moving thing. All right. You want to clap, right? Yeah. And it goes off the edge. Oh yeah, we never specified the size, which we should. I'll make it 500 by 500. So now it should be a little bit bigger. Gotta save that. We can actually see here how big it is. See, that's how big it is. It goes right off the edge. But let's draw a lot of rectangles. Let's say 100. See, in JavaScript, just the convention is to declare all the variables in the beginning, including things like I. Oh no, my editor. Oh, this is terrible. Because actually, if you were to declare I here, it's not actually, see, and here's a good point you should be aware of in JavaScript. In other languages, the body of a for loop is a lexical closure, meaning variables you define inside that body, inside those curly braces, can't be accessed from outside of those curly braces. But in JavaScript, the only thing that defines a lexical closure is a function. And curly braces just denote like, oh, these lines of code should be executed in the for loop, but it's not an actual scope. So if you say var I here, inside the for loop, you can actually access I afterwards. So it's just a little bit misleading to declare the variable inside the for loop. So it's just convention in JavaScript to keep it outside. That's known as hoisting, by the way. All the variables you define are, in essence, hoisted to the top of the function. Even if, like, here's something that's confusing about JavaScript is if you say var x equals 5, here you can actually access x up here. It's defined up there. Oh, it's cut off over here.
It's going to be 5?
And it will be 5. Well, actually, good question. I don't know. It's a subtle point. I don't know. Sorry. I don't know. Okay, I'll try it.
I want to call it something else.
Oh yeah, call it something else.
Text.
And this is string concatenation. JavaScript does that. Oh, I have to change this.
How do you do a comment in JavaScript?
Oh, same thing as in C. Where'd the script go? I'll just look at the script. Okay, so you're right. It's undefined. Anyway, check it out. For I equals 0, I is less than num rectangles, I plus plus. And then here we'll put the fill rect. And I'm going to make the width smaller I'm going to put it back to 10. And here I'll set y to be I. See, I goes from 0 to 100. So this will draw 100 rectangles that are spaced 1 pixel apart. But I want to space them like 3 pixels apart, so I'm going to multiply that by 3. And they're all using the same x, so they're all going to move across. There we go. But here's where we can visualize mathematical functions by drawing, these a lot of rectangles.
What's the random function?
Oh, there is a random function. It returns a random number. So I'm going to just declare the variables up here. And then set them inside of this function. So, yeah, the question was about random. There's a math library that looks a lot like other math libraries, but you have to call it with math.random. That gives you a value between 0 and 1. So if you want to spread that across the canvas, you would multiply it by the canvas dot width. So this is giving us random x values, but an evenly distributed y y values.
For the color, I'm assuming it can also take like hexadecimal, like
Yeah.
blue, but like so we can do math out.
Yeah.
And then 255.
We can. Yeah, I'll show you how to do that. But this is disturbing to me. I mean, it's just random noise. So let's make it a nice, smooth function. So instead of math.random, let's say math.sine of, say, I. Math.sine of I times canvas.width. So, but keep in mind, sine gives you a value between -1 and 1. So, but we want to have a value that's between 0 and 1 to spread it between 0 and canvas.width, or the canvas.width. So, well, first let's just look at this and see what this looks like. And I is an integer. Yeah, we'll have to add 1 divided by 2. I is an integer, but so let's divide it by, say, 100 to make it a slowly incrementing number. Okay, we're getting closer. What if we say divide by 50? It's looking more like a sine wave. Let's say 20, divided by 20. All right, so we can really see that it's a sine wave, but the sort of 0 of the sine wave is the edge of the screen. So let's move it over. So the line doesn't get too long, and I'm gonna add a variable called sine. Sine equals method sine of I over 20. And then this should be, it goes between 0 and 1. So to get it between -1/2 and +1/2, we can divide by 2. And then if we wanted to go from 0 to 1, we can add 0.5 to that. And so this now should be a value between 0 and 1. There we go. So notice how it gets cut off here. Why is that? Yeah. The x and y of the box is the upper left corner of the square. So if we want it so that it goes between so it doesn't get cut off anymore, but it goes right up to the edge. We need to subtract the width of that box from the the canvas dot width. So let's do that.
Can you also offset it by the rectangle that's starting point, 0, 0? Can you manipulate that? Can you will allow negative values?
Sorry, I wasn't following.
Yeah, 0, 0, like for clear X, and then when you're filling it as well.
Mm.
You know, 0, 0. You've gone over that briefly, but I just wanted to.
I'm sorry, I didn't quite catch the question.
Well, the function when we've been doing clear rectangle.
Clear rect?
Yeah, and above there's also when we're filling it.
Here it is, fill rect.
Yeah. The
Yep.
X, Y.
Uh-huh.
Can you offset that as well? Like, is that where it starts?
So XY determines the upper left corner of the rectangle. Yeah.
Okay.
So if you wanted to offset it, you would have to actually like add or subtract numbers here before you pass it into the function. Yep. There may be some part of the API that says, I don't know, it's in some other graphics APIs where you can change the mode where the XY actually defines the center of it,
Okay.
which is convenient sometimes. But I don't know if it's here in the canvas. You could try to look it up, but I don't know. So I was doing it's the canvas dot width minus width, which is defined here. It's 10. It's the width of the rectangle. So now it shouldn't get cut off anymore. And it doesn't. It goes right up to the edge. But we implemented animation, right? We want this thing to move. So if we just add time inside of this sine function, it'll start moving. But see, time is incremented by 1. But in a sine function, 1 is like a huge difference. So I'm going to have time go more slowly, like 0.01. And then it should start slowly moving. There we go.
Is it, just out of curiosity, degrees or radian?
Radians, yeah, it's just actually a sine function. It takes it as radians, interprets it as radians.
Can you do the same for X?
Yeah, I could do the same for x. Or for y, you mean, right?
Y. Because
So I'm going to copy paste that and change this for y, and then I'm going to declare the variable up here. So the question was, could you do the same for cosine? Yeah, let's do it. And then this would be multiplied by the cosine. And what's it going to be? A circle. Oh wait, I didn't. Hold on a second. Yeah, it worked. But notice one thing. Try to follow it with your eye. And notice how it's not, 100% smooth. It's got these little jitters. It like lags behind a little bit sometimes. You notice that?
Like a blur?
If you follow the motion's not completely smooth. And this is a problem because we're using set interval. And this is a problem that a lot of people recognized, and so they addressed it and they added another function to HTML5 called request animation frame. It's because it's waiting 20 milliseconds, which may actually, the time between these executions may be a bit more because there might be other JavaScript running. It waits 20 milliseconds and then it schedules it on the event loop of JavaScript. And if there's something else running, it has to wait for that to finish before it actually runs. So it may not really be exactly that time. So they have this function, request animation frame, that calls it in such a way that it's synchronized with the graphics hardware at 60 frames a second. If it can. If the code that executes takes less than 1/60th of a second, it calls it every 60 times a second, in sync with the graphics card, the refresh rate of the monitor. So I have this page open. If you just Google request animation frame, you find this page. This is the highest hit page. And it's kind of a new technology, so it's not consistent across browsers. So this is called a shim layer, which handles all the different browser cases and gives you one function that will work in all the browsers. We're in a WebKit browser, so this will work. So I'm just going to copy this. Oh, and window is the global object, by the way. So it just creates a global variable called request anim frame.
Is that a global object in JavaScript?
Yeah, window is the alias for the global object in JavaScript. So actually, when I declare this variable the canvas, it's the same thing as saying window dot the canvas equals blah blah blah. So I'm gonna use a different script tag just so it's separated. And I'm going to I'm going to paste that in. So copy it. Paste it here. So now we have this thing request anim frame available. And I'm going to use that down here instead of set interval, and we can see what the effect is. But the way it's used is pretty different from the way set interval is used. Look at this. You define a function anim loop, and then request anim frame. It actually requests only a single frame. It requests the next frame. So what you need to do is, it looks like it's recursive. So request anim frame takes a function, and it will schedule to execute that function on the next frame of, synchronized with the graphics hardware. So this is what it looks like. So I'm going to sort of copy that template. And by the way, it's using a pattern called immediate function execution. So it's just like this. In parentheses, define a function, and then immediately call that function. So this is a thing that's commonly used in JavaScript to just to create scope. Like actually, all the code on the page should be inside one of these functions so it doesn't pollute the global namespace. If you were writing an actual JavaScript library or actual code, in a page that has other JavaScript, you wouldn't write it like we're writing now, just creating global variables all over the place. It should be inside something like this. So actually, I'll do that now, just so we have decent code. I've split it into two lines. I'm going to put the top part over here. Function. I'm going to indent everything. And then I'm going to put this, the end part at the very end of our code. So now our code is inside a function that's getting called right away. But that function defines a local scope that we're working in. So we're not creating global variables. Let me just test it and see if it worked. Yeah, it's still working, but it's still using set interval. So instead, let's do this. It's going to be an immediate execution of a function. So this is like the skeleton right here. Define a function with no arguments, and then call it right away. And then the function body goes here. And if we define it like this, we can actually name it. Function frame or animate. I'll call it animate. And then let me look at the page again. Oh, I'll call it anim loop. That's a better name. So it's request anim frame, anim loop. So this will just set up a function that gets called in sync with the graphics card and the monitor or whatever. But we're not calling render. So inside we need to call render. And that should do it. This should work. And we need to get rid of set interval because we don't want them both going at the same time.
But another render on the top is scoped. How are you going to call it within that second function?
Oh, see, all these variables are inside the scope, the closure of the render function. But render itself is a variable defined in the same closure as this code that's getting executed. It's the same indentation level. It's in the same scope as the canvas and C and time. Mm-hmm.
I'm getting a problem where the second script tag you put in, the request NM frame,
Yeah.
when you're defining that, I'm not able to call it. It doesn't exist.
Request anim frame doesn't exist?
Right. When you look at request NM frame, you define it.
Yeah.
And
Yeah, it's defined here. And then when you go down here, it should be used. Let me try running my code. Let's see if it works. Maybe I'm having some mistake. Oh, you're right. It's not... undefined is not a function. Oh, no. Oh, everything's too big.
mine, the syntax error is request NM frame is not defined.
Well, let's see. Let me change it to, instead of window dot, I'm just going to say var request nm frame equals this. It should do the same thing. I don't know why it didn't work. Debugging time. I'm not sure. Well, it's 4:25. Oh, let me just see. Hold on. So request animation frame itself is there in Chrome. So I mean, you could debug it sometime. I don't know why it's not working, but we don't have much time. So I'm going to get rid of that, and I'm going to use the actual request animation frame, which is part of the HTML5 standard. Oh, that's not working either. Uh-oh. Oh, did I save the file? Request animation frame. Well, sorry about that, guys, but I think you get the basic idea.
Maybe take off the start.
Huh?
Maybe that's going to fix it.
What?
If you take off the function scope thing that you created.
Oh, this thing?
Yeah.
I'll try it. No, it doesn't do it. Well, anyway, I'm just wrap it up because we said we'd go till 4:30. But so yeah, we've covered basics of JavaScript, basics of the canvas, and animation.